Hello, this is Amy Brown, Director of Events and Education for Trade Press Media Group. Thank you for joining us today for the webcast 24/7 Remote Monitoring. Predict failure before it happens in your most critical assets. Our presenters today are Carol Kuzmich and Alfredo Areola. Carol has over 15 years experience providing innovative, creative, and forward-thinking offers to meet customers' needs. She has extensive experience in strategy and execution of new offerings through strong leadership and collaboration with internal and external stakeholders. Alfredo joined Schneider Electric in 2011 as applications engineer for energy management and control systems, with a focus in oil and gas automation projects. He now holds a position as a business development manager for the North America Asset Advisor team, with Schneider's cloud-based predictive analytics for electrical distribution equipment. The learning objectives for today's webcast include discuss risk reduction and improved safety, learn how to increase asset reliability, discuss tracking and prevention, and discover how to optimize asset life and performance. Before we get started with today's webcast, I'd like to cover just a few details with you. A live question and answer session will follow today's presentation. To submit your question, please navigate to the bottom of the screen and the Q&A button should populate. You can type in your questions to our panelists, and they will answer as many as time permits. Today's event will also include an interactive multi-choice polling question. We ask that you do participate in this poll, and your input is very much appreciated. At the conclusion of today's webcast, you'll receive a PDF copy of today's presentation. You'll also receive a link to a brief online assessment. Upon completion of that assessment, you'll receive your CEU certificate. Today's webcast will also be archived at facilitiesnet.com/webcasts. And with that, I'll turn it over to you, Carol.
Thank you so much, Amy, and thank you for all of the participants here today. Appreciate it. This is Carol Kuzmich, and I am the digital champion here at Schneider Electric. I'll be speaking with you today along with my colleague, Alfredo, and we'll walk you through an innovative strategy that will help you with business resiliency and sustainability during and after our current situation. So just to kick it off, I'll do a quick introduction as well as talking a little bit about the changing business conditions that we're all faced with. I'll also be talking through putting our asset performance management into action and this notion of customer resiliency. And then Alfredo will be talking through some of the real life customer examples that we have, as well as giving you a demo. So what are we faced with right now? I don't think that I have to tell anyone that we are in unprecedented times with not only the transformation of the marketplace, but also the catastrophic events that we have globally and all of the changes around us. And now we can just add on our current pandemic. And we've all experienced that in many different forms. And some people have hit that personally and some maybe not. But we're all in this together, that is for sure. So what do our companies need to do in this time of crisis? We all need to respond in some way. And right now, what you'll need to be thinking about is what is your value in the marketplace? It's on the line, as well as your brand reputation. I'm convinced that we'll come out of this stronger, but we'll have to take action in order to do that by creating a strong strategy, equipping yourself for future, enabling smart technologies, which we'll be talking about today. And all of those things put into place will make sure that you are making the best decision that you can for your future. So hopefully you're considering today some type of digital adoption. Right here we have an article by McKinsey that was done earlier this year, and it is creating digital strategy in time of crisis. So in this study, you can see the pure volume just based on the numbers to the right. that companies are taking action, and they're taking action in a big way. Those smart technologies will help strengthen the position that you'll have in the marketplace in the future as well. So please make sure to take a look at that article when this presentation gets sent over to you. So here's a study that was done quite a number of years back, but I think it still stands. It is companies like yourself that are looking at what are the things that are keeping them up at night. And really, if you look at the three highlighted here, maximizing return on assets, delaying CapEx expenditures, and also responding to aging infrastructure. Even though that the survey was done in 2010, it is still something that we need to consider, and just the pandemic situation that we're faced just added another layer tenfold of the pressures that we have. So as you can imagine, Schneider is actually going through that same process and going through a similar process to develop a strategy, a digital strategy going forward. Our digital strategy is around EcoStructure. And what EcoStructure does for our customers, there's a few listed here, and Amy had spoke about some of the learnings that we'll be going through. And I'm gonna just switch over to this next slide because it continues on, tracking and prevention as well as optimization. So considering what this is doing with our Industry 4.0, if you can imagine, those standards that are set around the Internet of Things are driving corporate-wide digital initiatives. The terms connectivity and connected, those are so much part of our world that it's just becoming our world. So let's put some of these concepts into action with remote monitoring. So what we did here at Schneider is we first took a look at some of the customer challenges that are out there with regards to power equipment. We found that our customers have a lack of early notification, sporadic data, and inefficiencies around best practices in using data to inform your decisions. Maybe you can see yourself in these pages. We also found that many of our customers are still in a very reactive mode or a time-based mode of maintenance. And what we really need to be looking at is on the far right over here, which is making data-driven maintenance decisions. What if you were able to pinpoint an exact asset and predict its failure before it becomes an issue? And how about if we're able to prescribe a course of action way early on so that you know what to plan out in your strategic activities as well? So really it's taking us from getting those early warnings and having to, react immediately on, or basically moving into this new way of looking at this data and being able to look at those early warnings and actually respond to it in a more collective and collaborative way. The last slide that I want to talk about is implementing some kind of asset performance management system. And at Schneider, we actually have a program that is available to all of you, which is called EcoStructure Asset Advisor. And what Alfredo is going to do is walk you through some real customer examples and provide a demo of what's available today. Alfredo, do you want to kick that off?
Absolutely, absolutely. Thank you so much, Carol. Welcome everybody to the call as well. Like Carol said, I've been working with the Asset Advisor team for quite some time now. So I want to walk you through some of the different case studies that we have for Asset Advisor. Basically, these studies highlight three of the main key pillars of what we can do with this digital brick or this digital tool, right? So next slide, please. So first is the case for asset life optimization. Okay, so what we can see here is we have a transformer where we're monitoring temperature, on some of the different parts of the transformer inside. So we tend to place sensors on taps, windings, low voltage connections, medium voltage connections in this case. And so first we detected a high temperature, right? So temperature it's higher on one of the windings on phase B. And up to that point, just detecting a high temperature number that is triggered by a threshold, and just being able to record that and trend that. It's something that any HMI SCADA historian can do. There's nothing fancy about it. It's something that using any piece of software we can accomplish. What your historian or your SCADA or your HMI cannot do is being able to combine different pieces of information like historical loading, the temperature at which is running, environmental conditions, etc., and use these to detect how much of the transformer's life we are adversely affecting by running this transformer under non-nominal operational conditions, right? So we're taking life away of this transformer. Why is this important? To know if we are aging a piece of equipment faster than we should, because that talks for total cost of ownership, right? We buy a piece of equipment thinking that it's going to last 20, 25, 30 years, right? But depending on how we are using it, same thing that we do with our bodies, depending on how well we take care of our bodies, we might live, 90 years, or we might die at, age 65. So it's the same thing with a transformer, with a piece of electrical equipment, right? Depending on how we're using and operating that equipment, the conditions for how long this is running hot, how electrical stress is affecting this transformer, we're chewing away that remaining life, right? And so this is important because we think that we may be thinking that this particular piece of equipment might be a liability for our infrastructure and our operation, not before 20 or 25 years, when in fact, because of the way we've been operating this equipment for the first 10 or 12 years, it might already represent a liability or a risk, at year number 18, right? And furthermore, one more thing that we do through our solution is because of our online engineering team, what we call our connected service hub, which is not just a call center. These are professional engineers who their job is to monitor our customer sites day in and day out. They are able to provide that prescriptive approach that we show in the bottom, the way forward. Okay, it's not only we're detecting this, you're chewing out the life of this piece of equipment faster than you should, but what are the recommended actions that we should take in order to bring this particular asset back to a nominal aging percentage, right? So that we will provide actionable recommendations. So this is case number 1, asset life optimization. So now let's go to case number 2. Case number 2 is asset critical event prevention. So in the case of this particular customer, we have an HVL switch where we have an ambient and humidity sensor inside of the HVL switch, and then we have another one outside in the electrical room, right? And up to that point, same story. You want to read a humidity percentage, and you want to read temperature. It's again something that any SCADA can do and trend, right? Any historian, any DCS, any whatever you want to call it, local software can do this trending and capturing of this data, right? You can set some thresholds and limits. The difference between that and analytics is that we actually have an analytical tool in our toolbox that can actually detect the dew point. This dew point calculation basically is telling us when condensation, or how far we are in time from actually having the presence of condensation inside of the equipment. Right? This is relevant because water and electricity don't work as well. So we want to know, after we've been monitoring, the behavior of the humidity and the temperature inside of the HVL switch, right? Now we can determine when is the critical point to prevent a critical event. Furthermore, the recommendation that our online engineering team provides, knowing HVL switches very well, is go and check, the fuse. Go and check if the heater inside of the equipment is properly working. So we provide those recommendations. What should we do to quickly resolve this issue? So that was asset critical event prevention. So lastly, the third pillar of what we can do is not that it's everything we can do, but these are some of the three strong pillars. Is what we call asset dynamic maintenance optimization, which means shifting from what a lot of people call preventive, and many people call it predictive, but it's really preventive. It's schedule based. I maintain my equipment every 2 years or every 3 years, or in some instances every year. I do my traditional PM rounds. I do my traditional PM checkups, IR scanning, and all these different activities, trying to prevent a maintenance issue from happening, right? When we have continuous monitoring, right, 24/7, and we have people who are analyzing the behavior of the assets, the electrical assets, then after establishing a baseline of operation, we can actually start making what we call dynamic maintenance recommendations, which is shuffling the expected traditional schedule-based maintenance, which in some cases, like I said, is 3 years, or it can be annually, depending on the philosophy of each company. And we can now say, okay, based on the utilization of your assets, the electrical stress, different factors that we monitor, okay, and also foreseeing that there's not that you're going to continue to use the assets in a similar way, okay, in this baseline that we created, okay. We can shuffle from, for example, like the slide says, and this from an actual customer, we can shuffle from 3 years to 6 years maintenance cycle on a circuit breaker, medium voltage. We can shuffle from 2 years to 4 years in low voltage breaker. But however, there are some drives, for example, that are presenting some health issues, some over braking, some over temperature. And so in those particular drives, what we want is we want to shorten the maintenance cycle to make sure that they don't fail on the job, right? Next. Now, when we talk about particular customers that we have helped, I'm going to quickly present to you 3 different cases. So this is the case of BASF, the chemical company in the US, a German chemical company, the largest chemical company in the world. We have a somewhat large system with them and expanding. More than 100 variables to be monitored. One of the challenges that they had when we first approached them is they had just built this state-of-the-art substation, brand new equipment, everything with communications, everything monitored by a DCS and by a power management system, right? There were a couple of things that they wanted to do. First, they wanted to be able to remotely monitor some of the electrical parameters that were happening inside the substation. Some of the BASF sites are supported remotely by instrumentation and electrical engineers that sit on the larger sites. And so they wanted to be able to troubleshoot and help some of the local people, right? Some of the local resources. Also, BASF had already invested a lot on smart devices, smart relays, smart trip units, UPSs with communication, right? So they wanted to also make the most of their data and obviously increase the visibility of the health of the electrical equipment, right? So we started monitoring with them. We have detected several optimizations and things that we have alerted them, things that could affect them directly in the immediate future, and things that, for example, voltage variations. That was one of the last topics that we discussed with them. Some voltage variations coming from the utility that if they go untreated or unnoticed, they could adversely affect the life of their life and the installation of some of their electrical equipment, right? So it's case number 1. Case number 2, it's also one of our first customers ever, Rochester University, or University of Rochester Medical Center in Rochester, New York. The journey for this customer has been very particular. So first of all, the challenge that they had was to maintain the power infrastructure in the hospital. Of course, when you talk about a building, especially, you are always concerned about the lighting in the building. You're always concerned about, the spaces within the building, right? But University of Rochester put an emphasis on what is powering everything that's inside of the building, what's powering everything that keeps, the lights on and OR, etc. So obviously they started looking at how do we better maintain, how do we make sure that we never lose power, right? and that our equipment that's powering our critical infrastructure remains on, availability, right, uptime. The way they were conducting some of their maintenance was, like many others do, sending on-site staff out, to take physical measurements, write them on a piece of paper, keep them in an Excel spreadsheet. Same thing, PM rounds, similar way, keeping on a spreadsheet, etc. And it was getting very costly, right? Especially because of the number of equipment that they had to manually monitor and maintain. So when we first approached University of Rochester, we actually ran a small pilot, just a handful of assets, which is how a lot of customers begin this digital journey. And the story goes on and on for this particular customer, same as with BASF. We started with a handful of assets just to start testing the technology, see what you can get out of it. Then it came the recognition that, okay, not only do we need asset advisor, we need a wider infrastructure to be able to monitor all these other assets, right? So we need a network with a central HMI that consolidates all the information from the critical assets, and we can use this HMI as a huge data concentrator. We can also use it for PQA analysis, power analysis, power quality analysis, and then from that point, be able to push the data into the analytical system, right? And be able to have that 24/7 dimension and dashboards for asset advisor. So, like I said, this has kept growing because it's not now only asset advisor, which is, like I said, it's the technology brick, but there is also a maintenance contracts in place, right? Where now Schneider is able to support them both digitally and predictively through asset advisor, but also when it's time to focus our attention on a particular asset that's suffering, they are supported by a maintenance contract in the back. So like I said, this is a story that has grown over time on multiple different aspects in order to create a more reliability-centered approach for the infrastructure of this particular hospital, right? On the different events that we have prevented from happening on this hospital, from a partial discharge, a transformer failure, to a hotspot, a predictive detection on a particular piece of switchgear. The savings here on equipment that has not failed is nearly $1 million, right? So this is case number 2. Now, case number 3 is a more recent case of a site we connected within the last year or so. This is a Calgary airport in Canada. They move over 16.3 million passengers to 80 non-stop destinations globally. For them, the challenges they had was obviously 24/7 power availability. So their availability percentage per year is over 99%. Basically, an airport never stops. When you have to stop to perform maintenance on equipment, it has to be on very specific dates, on very specific times. It has to be very fast, very quick. And so therefore, knowing that something is not going right and being able to plan for that and everything that planning involves, it's very important. Obviously, we're also trying to reduce costs of unexpected shutdowns and failures. And so obviously some of the benefits for them are around labor time savings, because now remote data availability, it's present. So therefore, when something is not going right, they're able to plan much better for that. Obviously, the way they were conducting their rounds and the way they were conducting their PM activities, like I mentioned before, also with Rochester, it was in a manual way, right? So they were sending people physically to take measurements. Some of them were automatically coming to an Excel spreadsheet, but it was taking a lot of time, right? To go and sort through all of that data, and it's always subject to the interpretation of the person who's looking at the information in many instances, right? Some of those visual inspections. So we're taking that subjectivity out of the way and replacing it with factual data that's coming from the assets, right? And of course, it's having a great impact in reducing downtime and increasing availability of the electrical infrastructure for this customer. So next, please. Just to finalize, like I said, one of the key of the keystone of the entire offer, okay, is the technology, but it's also our connected service hubs. Because while technology can give us a result and can tell us, hey, this is deviating from the expected predictive model. Hey, my statistical analysis tell me there's something going wrong. We want to go one step forward, and we want to be able to, like I said, support our customers with recommendations from industry and engineering experts. What should you do to resolve this issue? So our connected service hubs support different geographies, and more than geographies, they support either a time availability, so 24/7, right? And some of them also support a specific language for a specific region. So as you can see, we have several connected service hubs around the globe that help us cover multiple time zones and also help us cover multiple languages, right? So next, please. A little bit of what we do, okay? So like Carol said in the beginning, especially in these very special COVID times, something that has become essential is remote, the ability to remotely monitor equipment, like it was for BASF. For BASF, it was this way before because they were still supporting, they were already supporting some of their internal customers remotely, right? Especially the engineers. So obviously that remote essential, right? So be able to have dashboards, expertise, and assessments in a remote way. Also, the on-site essentials, like I mentioned in the case of University of Rochester, okay, is not only about what we can do remotely, but in many instances, okay, when we detect that something is not going right, when we detect that we need to perform a specific maintenance service on a specific asset that's suffering, like for example, in the case of BASF, that they had some drives that were suffering because of different problems, and they need to now focus their attention specifically on those drives versus the entire infrastructure, right? That's where our maintenance contracts, what we call our maintenance contracts connect, our ASP Connect is the name of our offer, is basically that perfect combination between our traditional maintenance plan, but aided or supported by the digital aspect in order to optimize costs and optimize activities. So that on-site essentials is the spare parts available at a discount, the on-site assessments. We need to send an FSR, resolve the issue really quickly, bring the equipment down because we're now there detecting partial discharge, or a transformer is gassing, or a motor, is having a bearing problem. Being able to dispatch the resource at no extra cost is included in the bundle, right, of the maintenance contract with the technology break asset advisor. And obviously this helps you as a customer to plan for the future, right? Better OpEx planning, better CapEx planning for new facilities, and also provide other services like cybersecurity services that are embedded within everything we do, right? Finally, on the bottom, this is my personal opinion on this. I think we are leading the industry in the number of, when we talk about electrical assets and secure power and cooling assets, we're obviously leading the industry with more than 300 connected sites around the globe. 50% of the assets that we have currently are assets under management and that we're selling. And obviously with the number of field service engineers and service locations that we have. So the fact that we're digitizing our traditional offers, we're digitizing our field service engineers as well to be able to support the feedback that we receive from the technology break, the asset advisor break, it's very important. So next slide, please. So now we're gonna switch quickly to a demo. So this is what we call an offline demo. So it has some limited capability for privacy reasons, obviously, of our customers. So very quickly, this is the dashboard that you as a customer would see if we deploy something like this. Let's say, for example, that you are a multi-site customer. So you have 3 sites in France or in North America or whatever, and you want to assess, the health and how your assets rank in criticality and in condition. So this is how you log into the platform. You'll see a map, you'll see your sites, and you'll see in red, green, and yellow kind of like a stoplight configuration which sites have critical events, which sites are in good health condition, all the assets, etc. So if we go here to a quick example, okay, we click on site number 1, and this will immediately open. So let's go from top to bottom. Okay, first you'll see your company name, the number of assets that we're monitoring, the number of assets that have a health index. Okay, then you will see the global risk level, and the global risk level is the percentage that we always want to keep. We always try to keep that down. Okay, the global risk level basically is telling you what's the risk of your facility of having an incident related to a health condition of the assets, right? Then you see the health or with the health or criticality matrix. Okay, this matrix gives you a clear visualization of how highly, medium, or low critical the assets are for the infrastructure, and how good, medium, or poor their health is, right? This ranking, this is a very common question. How do you do this ranking? Well, we do this ranking in accordance with the customer. So we have to do a criticality assessment, which loads, which infrastructure is more critical. And so we rank along with our customers, we put the assets in the proper ranking. So this criticality matrix and how the assets rank, okay? So you see here we have one asset that is highly critical and is medium health, and 2 assets that are medium critical and are medium health. How the assets rank on the criticality matrix, as well as their age and usage over time, directly affect the global risk level, right? So if I have an asset that's, let's say, a transformer that's 25 years old and it's overloaded, right? And it's not operating under nominal capacities, etc., obviously it's going to push this number down. So the higher this number goes, what that means is we have some actions to take in order to minimize the risk in the facility, right? So in the bottom, you also have the list of the latest alarms that are happening on the site, and then it shows the last report that was delivered for the facility. Our connected service hub, the online engineering group, they deliver 2 types of reports. One of the report, the standard way is to deliver it once every year. That's what we call the summary report or the annual report. That report contains aging percentage of all the assets on any given year. It contains the overall health assessment of the assets, and it contains the maintenance recommendations, okay? So like I said, if we see that all the assets are fit or in good fitness, and you were planning to do your maintenance in November, we might suggest that based on this, you can actually push the maintenance 1 more year, so therefore directly affecting your OpEx budgeting, right? One example. The other type of reports that we deliver are unlimited reports, and these are what we call the event reports, and these are event-driven, right? So if we have a particular asset that we detect that something is going out of the model, the expected model behavior, okay? The statistical analysis tells us that, yeah, this is a vibration that is now trending out of the particular parameters and the baseline we established, or whatever it may be, right? We're going to conduct a root cause analysis and resolution path. And those number of reports are unlimited across a monitoring year. It basically depends on how many issues or things the platform detects or predicts. That just means that the service hub will get engaged with our customer. We will deliver what we've seen on the platform as far as data goes. We will deliver to our customers what we think is the best path to start what we think is the best recommendation to start on the path of resolving this issue. And then our online engineering service stays engaged with our customers, because of course we might have to deploy someone to the field. So we will stay engaged with the team on the field, whether it's an external contractor or a Schneider providing that service. We will stay engaged with the team resolving it, so that when we resolve the issue and it's all back to normal, they can complete the root cause analysis report, give it back to you, upload it to the platform, and then you have a clear record of what happened and how it was resolved, right? So now going a little more into the granularity, if we click here, for example, on this breaker, now we can see particular aspects of this breaker. So we can see the corrosion aging, We can see the electrical wear of the breaker, the mechanical wear, the aging of the protection relay, trip unit. On the bottom, we can see all the different parameters from the nameplate of the breaker, right? You can also see all the events on that specific breaker, okay? If we go, for example, to this transformer down here, we're gonna see very similar things, okay? You go to the environmental conditions and you can see how we're monitoring here the ambient temperature and ambient condition and humidity. You can also see all the energy parameters, so power factor, current voltage, harmonics, if we're monitoring harmonics. And then lastly, if we have thermal sensors on this transformer, for example, you'll be able to see how we're monitoring the temperatures, the delta T between temperatures. You will, as a user, you're able to also log into the page and create your own thresholds and be notified upon those thresholds, okay? Those thresholds are not the same thresholds as the algorithm thresholds, but those are for your own personal notification. And so the platform allows a certain degree of self-monitoring for our users, right? So these are some of the key highlights. There are other functions within the platform that I think are very important to mention. If you click here on the more, we have what we call life cycle services. That's something that's coming up on the platform in the next few months. And basically, this life cycle services tab will help our customers understand, as an asset is aging, what is the cost associated to replacing that asset in terms of labor, parts, etc., so that you can plan better. You say, okay, maybe the platform is telling me I have this asset which is already at 90% of its lifespan. Where Schneider is recommending you to change it within the next year or 2 years or whatever. Typically the question is, what's the cost of the replacement? How can I justify my investment? Well, the platform will automatically help you to get some of those answers, right? Then if you have what we call, like I mentioned, our maintenance contract connect, so asset advisor platform plus a maintenance contract to support you. You also have access to this, what we call MyField services. And MyField services is the repository where we will upload all the different work orders and any activities that were performed on the field. And you can digitize them. We will put them on MyField service. You have access to all those records. And then you also have access to, for example, a safe repository where you as a customer can upload different documentation, technical documentation around an asset. And one of the most important features that I think this platform has as an extra added value is these trainings and courses where you can access a free training relevant to the assets that we're monitoring, as well as some paid training, like for example, safety training or arc flash mitigation training, stuff like that. You'll be able to access the training directly through the platform as well. And we also allow the platform to be directly linked to some of our other advisor platforms. But for example, in this case, we're showing here, we have a platform that is called a Pump Performance Advisor, which helps our customers understand how they can save money through optimizing the usage of their pumps, energy-wise, etc. So we're also able to link asset advisor to other advisor offers that we have within Schneider, right? So those are some of the highlights of the platform itself, okay? And this is what I wanted to show you as a quick, brief demo. One last thing, just so they don't forget, up here is where you can contact support. So for example, if you as a user need to contact the connected service hub, because you see, oh, my temperature in one of my faces is trending up, and I just want to understand if we need to take any actions or whatever. That contact support is where you will have the phone number and the email address for the engineer who is in charge of monitoring your site in regular business hours, and you'll be able to get in touch with them and ask any questions or whatever. So it does allow also some interaction with our connected service hub team. And I think as far as the demo goes, that's it.
Great. Thank you, Alfredo. I think now we're moving on to our poll question for today. So we have one question for everyone in the audience. We'd love your participation in this poll. Would you like a rep from Schneider Electric to reach out to you with two answers, yes or no? If you could take a moment, the screen should have popped up with our poll question. We'll leave that open for a few seconds while you have a chance to answer. Great. Well, I think that should wrap up the poll. So thank you again for your participation. And with that, Alfredo and Carol, I think, are we ready to get into some of the Q&A questions that have come through?
Yeah, sure.
Great. Just a reminder, you can use the Q&A panel on the bottom of your screen to type in your questions for either Carol or Alfredo. So we do have a few that have come in. I know Carol's been answering a few of them in chat format, but I think it would be great if we could kind of review those for the audience in verbal format as well. I know you mentioned a few of them you'd like to get Alfredo's take on it.
Yeah.
So the first one is, what is your thoughts on data collection debouncing or rebounding? Do you prefer to collect more data than may ever be needed or tailor to what's collected?
No, so we have a specific data set that the platform needs in order to do some basic functionalities, like for example, producing a health index for the asset or producing the aging percentage of the asset, right? So there are some mandatory points that we need per protect. Let's say, for example, for a protection or from a protection relay or from a trip unit. Same thing for a transformer, etc. So, like I say, we have to at least comply with those minimum data points required by the algorithm. But the more data we have, the more context we have, right? So, of course, there are other data points that we might be able to incorporate to bring more context and increase the monitoring and predictive capabilities. So yeah, I mean there may be some data that is useless, and so we can determine that. But yeah, typically the more data we have, obviously the better the result will be, right?
Perfect. And Alfredo, you mentioned with Rochester University, they started off with a smaller segment. Is that where you recommend most people start, you know, taking a specific segment as opposed to starting on their entire facility?
Well, my specific take on that is rather than starting with a specific subset of assets, this is my personal preference. I like to analyze what's more critical for the infrastructure, depending on the segment. If we're talking about oil and gas or food and beverage, or depending on what the customer does. What I like to understand is, okay, from the moment we intake power from the utility, right? What's that critical path of the power down to the critical loads that, you know, if this load stops, it adversely affects my process, my operation, costs me money, right? And so in my particular view, I would monitor one specific, let's say, chain of electricity, right? So down to the motor, I would pick out that critical motor from a critical process, maybe the low voltage switchboard or the MCC upstream of that motor, the transformer upstream, the medium voltage breaker upstream, all the way up to that, maybe that transformer that's taking, power from the utility. I think that makes a lot of sense because now we're monitoring a critical path of power, right? And the assets along the critical path. So that's my personal preference. And in many cases, the result of that will be 5, 6, 10 assets, right? Yeah. So it's still a small subset, but it's you're better positioned to be able to prove that relationship that they have in lieu of a critical piece of infrastructure.
Perfect. We've got quite a few questions on monitored devices. Do monitored devices, do you recommend having an API or some functionality to integrate them with other monitoring analytic platforms?
So let me read this question here. So you monitor devices have an API or some functionality to integrate them with other monitoring or analytical platforms. Yeah. So the sensors, the sensors that we have, I know we didn't touch on the instrumentation that we typically use, right? But if we talk about the instrumentation, most of the instrumentation that we use will have an open Modbus communication port. So therefore, all of these sensors you can actually integrate up to a third-party SCADA or a historian or something like this. And then the analytical platform, the asset advisor platform, is flexible enough that we can, your electrical SCADA, your historian, your DCS, or even a cloud to cloud, if you're already bringing data, we're already doing this with a couple of customers, where they are bringing data from their assets to their own Azure or AWS cloud. And then on a cloud-to-cloud basis, they are sharing the information that we need to perform the analytical on the electrical, right?
Mhm.
So I mean, there are a lot of, that could be a longer answer, but the
Sure.
short version of the answer is yes, we are very flexible in terms of APIs and how the data flows locally and then out to the cloud. Yeah.
Great. And we've had a few questions. We've had two that are talking specifically about archiving that monitoring data, or if, by an act of God, there needs to be accessible later or remotely. Is there that kind of capability?
Yeah, so let me talk about first, I remember seeing the question about the archiving of data. I think it disappeared, didn't it? I want to take a look at that.
I think it's under the dismissed.
Oh, that is missed.
Is all monitoring. Yeah, look at that one.
Is all monitoring done in real time?
Yep.
And can it be archived? Yeah. So yeah, the monitoring is all done real time. Obviously, we archive the data historically speaking, for the entire years or whatever time we're monitoring, right? Now, because this is sold as a service, okay, and this is a typical question that we always get from customers. We only host the data for our customers. We don't own the data. The data is the customer's data, and we put this on our contract. So in the case that, for example, at some point you want to cancel the service, you say, hey, I'm moving on, I don't want to follow the service, to follow the service anymore. Of course, the hardware is yours. You pay for the hardware stays, any sensors we install are yours. But in terms of data ownership, we repatriate the data to you. We give also the customer a period of time to, for example, download their information directly from the platform, both the raw data and the treated data. We give a grace period of 30 days. Once you've downloaded the data, we delete the data and we issue a certificate that we do not longer host any more data from you in our servers. So I know that's that went a little further from what the question was, but I think it's a typical question I get as well. So
Yep.
No, that's great. Carol, anything you wanted to add?
I don't think so. I answered a few of the questions over just the chat. So I don't know if it looks like we're getting a bunch more coming in. So I don't know how you want to handle.
Yeah, let me go to some of these. Okay. So I know Hope will ask, does EcoStruxure work with other manufactured equipment? The answer is yes. There are some caveats when we talk about breakers, because breakers are such a mechanical piece of equipment, right? If it's a third-party piece of equipment, we need to collect some specifics about the mechanical design of the breaker. So as long as we have that information, yeah, I don't foresee a problem. We have, in terms of electronical smart devices, in my segments and in my experience, we have integrated protection relays from GE, from Schweitzer, from Siemens. We are monitoring transformers from multiple OEMs, drives. In my particular case, in mining, we have incorporated a couple of drives from Danfoss, from Yaskawa. So as long as, I think it's rather than seeing it from an OEM perspective, it's a what data can this device produce? And if that data can produce the data points that the algorithm is expecting on the other side to produce a result, then the answer is yeah, we can bring it in.
Perfect.
Then the question, is your system based on statistical tools or does it include some advanced artificial intelligence ones? It's both. Yeah, it's both depending on the type of asset and what we're doing. That's a very long and technical question to answer. So if Carlos wants to give us, Carlos, if you want to leave out your contact information, I've done sessions with other customers where I invite our data scientist and we can deep dive a little more into what we use and what we do for specific cases. Right? At what stage of the project do you prefer to determine the points of data? Planning, design, construction, or operation? Well, if we're talking about a greenfield project, certainly during the design phase. There are some greenfield projects that we're doing right now where typically during the design phase is when you're also programming your local HMI, your power management system, or your power monitoring system. So yeah, that's a critical stage where we want to determine which data points flow where we are connecting. In some instances, some customers prefer to create a separate network specifically for the monitoring piece, separated from the power management system network. So that implies, for example, a second communication port on a specific relay or on a specific drive. So yeah, I think the design phase is definitely the one where we want to start determining which data points where the data is going to flow. How much of the data points can we capture from SCADA or circuit breakers? Well, again, Mohammed, we have a predetermined list of data points that we need on a per asset basis. So again, on a follow-up call, I could share, that complete list. We have actually in a specific presentation or document where we go on for each asset, what data points are mandatory, what data points bring more context, what we do with those data points, how we treat them, and then what is the business value that it brings to monitor those data points. Circuit breakers certainly cover on that presentation. Is real time as per hard real time control? I don't follow that question. But maybe the way we'll answer that is we monitor real time, but for condition monitoring, real time doesn't mean milliseconds. I think we didn't mention these. These are technical aspects we didn't mention on the presentation. But for condition monitoring and condition analytics, right? We sample information from the equipment in the field every 10-15 minutes. Because we don't need to be at the resolution of milliseconds. Okay, that's I think the difference between a SCADA system and a condition monitoring system. When you're a SCADA system, you want millisecond resolution because you want to know when a trip occurred, what was the sequence of events that led to the trip. You want to be able to do oscillography analysis. Here we're talking about health condition of an asset that typically, when we talk about reliability center maintenance, typically this is something that happens over time, over weeks, months, years, right? So there's no point on sampling, for example, temperature at a resolution of milliseconds. I actually had this discussion with a mining customer yesterday. A sampling rate of temperature in a bus bar of every minute, every couple of minutes is more than enough to be able to correlate that information, come up with a prediction whether or not this is a hotspot, right? So anyway, that's the way I would answer that question. Can this system be integrated in an already existing BAS monitoring system, or do you install an entirely new monitoring system? There was an acronym used there. I don't know if building means building advisor system or...
It's building automation system.
Oh, building automation system. Well, your building automation, it can be, but your building automation system would be more of a data collector, okay? So all the data from the assets would flow to the building automation system. And then from there, we would push that information to the analytics on the cloud. And then we can create an instance within that building automation system so that within the environment of the building automation system, you can pop up the screen for Asset Advisor, although that's connected to a URL on the background, right? We've done a similar implementation with our own building automation system in the past. Are you able to collect vibration data or variable speed gearbox with multiple gear sets? We can. We have a couple of examples, not in North America, but in the rest of the world, where we're monitoring vibration data. Okay. However, I have to say that we as a company, for specific applications, let's say the larger motors is where we will recommend vibration. But for certain motors, like low voltage motors and medium voltage motors, we are using a technology called motor current signature analysis, which is basically using high sampling frequency CTs to monitor electrical parameters, current and voltage out of a motor, the cables from a motor, and run a statistical analysis on the current and voltage signature to determine mechanical problems on a motor. So again, that's something that we can give it some follow-up. But yeah, that's something that we can also integrate into the platform. Can this system mean, okay, yeah, I will answer that one. Is there a way to track equipment and work that has been done so you have a history of that work has done a piece of equipment? Yeah, so the platform has the safe repository to do that. Yeah. Can this include manufacturer of the equipment, including that date and other data? Can also this product be used to determine if the new device is working in order, or if there is a defect in a new item, say a motor with high temperature readings after startup? Yeah, yeah, that's something that we also help doing. As a matter of fact, I mean, similar to your question, some of the issues that BASF had, for example, on the drives, where we're not going into all the details, but when this substation was actually started up, some of the drives and the motors were acting up, and so during that stabilization period of the electrical equipment, as new equipment, there is a stabilization period when you start up the equipment, and we actually caught up on a couple of optimizations and a couple of things that were not going right with the drives and the motors. And so we were able to provide feedback to the customer to say, hey, this drive is acting up, is showing up these codes. And so actually the investigation led us to know that, or led us to determine that the rating on the drive was incorrect. And it was a design issue, actually. Like I said, I won't go into more of the details. Actually, for BASF, our partner and myself, his name is on the presentation, Lee Perry, we wrote a paper for the IEEE PCIC, which is a conference for petrochemical that happens every year. And last year in Vancouver, we presented a paper that talks specifically about the case of what we did in Beaumont. And specifically, we highlight some of the findings that we did at the beginning with those drives and those motors, specifically to that point, design issues that were detected as we were starting up the substation. So.
Perfect. And it looks like we've got one last question from Carlos. Can the system interface with other software products for managing work activities where history of interventions are kept?
Yeah, so I believe he's referring to systems like, for example, IBM Maximo, right? So the answer is yes. However, because each customer has their own implementation of a system like SAP or Maximo, there is no standard connector. So that's something that let's say the base offer won't have. If you want the system to interface, let's say with your Maximo system, we will have to do a specific quotation to know how many hours of development we will need to create that interface. Of course, there are things that are standard, but there are other things that are not. So we need to take a look at that on a case-by-case basis.
Perfect. Well, that brings us right to the top of the hour. So thank you again to Carol and Alfredo for this wonderful presentation. Just a reminder, we will be sending out a copy of the slides, and then the archive of today's webcast will be available at facilitiesnet.com/webcast. Carol or Alfredo, any last minute comments you'd like to make?
Nope,
No,
I
just
think that I'm good. Thank you for listening. Sorry, Alfredo, if I stepped
no.
over. Thank you so much for listening, and I'm hopeful that the people that needed some further clarification or details, that they leave those names with you so that we can connect going forward.
Definitely.
Absolutely. Yeah. Thank you so much, everybody, for your time. Thank you for putting up with us for about an hour. And yeah, you have our contact information. We'll be very happy to support you, help you explore. I think my last comment is no commitment. If you want to reach out to us and just ask questions, I think first and foremost, before we recommend any path, particularly speaking for me and my colleagues and my team, we want to understand what are your needs, how we can help you become more efficient, prevent issues. So we want to first understand and then see if we can walk on this path together. So thank you all for your time, and yeah, hopefully we'll talk soon.
Wonderful. Thank you very much. Again, thank you to Schneider Electric for today's webcast, and have a wonderful day.